folks, as I said in the previous video, I hope it'll continue to be just as warm as it is now so I can finally start building the cam chest because honestly, I can't force my laziness to work in cold weather. Yeah, the problem was not so much that I was cold, but in my goggles, which constantly fogged out and I couldn't really see what I was doing. So at first I was cold and the New Year holidays came around, then for a whole month I was just lazy and haven't done a thing, then the weather became warm and a whole lot of other work appeared. Alright, look, let me tell you this. If you need to come up with some kind of excuse, write me down a message and I'll help you do it, because as you can see, I'm a master in this matter. And one more machine gun burst with questions about how I'm gonna stick a carburetor in here. Well, everything's quite simple here because between the two heads I'll make a small intake manifold on which the carburetor will hang. I foresee that some will say that I myself said that you shouldn't install one carburetor. Well, yes, you shouldn't on an opposed engine. This is not an opposed engine. Also a few words about welding and machining. Following the advice of about 1 billion people, you shouldn't record the welding process because it can somehow harm the camera. And second, many are afraid to ruin their eyesight by looking at welding through the video. And about machining, I won't show the whole process of machining either, because I'm such a machinist that even earthworms laugh out loud, but if I turn the camera on, the total entropy and the destruction of cutters begins. So there will be some welding and machining fragments, but not all of them. There are a few things you need to understand before we start. All that I've done here in this chaos that you'll see here in a moment is just a testing, pilot version designed only for the first engine start. After I start the engine, I'll redo it and make everything out of good materials and with proper heat treatment. No, I won't. The first thing I intended to do was the crankshaft gear so that I could repel from it when building the entire timing. But since I'd already decided on the camshaft gear, then on the contrary, the crank pinion gear had to be made referring to the camshaft gears. And according to the HPGWG method, handcrafted production of gears with a grinder, which I used when installing a magneto on the nipper, I made a crankshaft gear, made it from the same gas 52 axle shaft that the crank pin was machined from. To do this, I annealed a piece of axle, bored a hole in it, and made a keyway with a parting off cutter. After a high-tech gear teeth cutting on my angle grinder milling machine, I got the ready-to-install pinion gear. What's important to know about any gas distribution mechanism is that the camshaft rotates 2 times slower than the crankshaft, so the crank gear should have 2 times fewer teeth than a camshaft gear. There's almost no material left on my gear in the keyway area, which is not very good. If all of a sudden this gear explodes, well, then I'll just replace the bent valves, reduce a bit the crank pinion in diameter, and make a gear with more meat in it. Next, I began trying on camshaft gears and looking for a camshaft that I can take the lobes from. Now I'll explain a little more about camshafts. I decided to make a camshaft system similar to the ones that were used on Indians from 20s and 30s. Of last century, for several reasons. First, this system is quite simple and it requires only a few gears to be installed. Second, the fact that one cylinder needs only one lobe on a camshaft. So 2 cylinders, 2 cams, and it's possible because of the followers placed above the cam lobes, and also due to the fact that in any engine with valves, the intake valve opens right after the exhaust valve closes, and there's a moment when both valves are open. It's called a valve overlap, we'll talk about that a little later. So, one lobe opens the exhaust valve first, then it opens the intake valve. It seemed to me as a simple and ingenious solution in favor of which I refused to install 4 camshafts, thereby saving 2 gears. And from the very beginning I wanted to make the timing as simple as possible and with the smallest number of gears inside. And a third point is the ability to replace the lobes on a camshaft at any time. So you can take any camshaft, machine off the lobes from it, press these out and put on the new ones. For instance, for Indians, there are whole sets of lobes for specific types of riding and engine operation purposes. Yes, Indians got their lobes riveted to the gears while mine are just tightly pressed, but in the future I'll drill the lobes in gears and secure them with rivets. So as a cam lobes donor, I chose a camshaft from a Dnepr 11 just because I had it lying around with one of the lobes being completely destroyed, in a destruction process of which happened this. Yeah, this is a Chinese Dnepr lifter, most likely made from black soil and hardened with horse crap, and not only did it kill itself like this, but it also murdered my pretty much brand new USSR camshaft. So the murdered camshaft was mercilessly cut apart and 2 lobes were machined from it on the lathe. I also machined 2 shafts for all this and pressed the lobes on them. Then I undertook making the magneto drive gears. In this case, I could make the magneto drive in several ways, either from one of the 2 camshafts or from the crankshaft. In the case with the drive from the front cylinder camshaft, I had to use a counterclockwise spinning magneto. But a counterclockwise magneto is a pretty rare piece, so if it breaks, it'll be quite difficult to find parts for it. Therefore, I decided to install a regular 2-wired magneto from a tractor starter engine. But since it's a clockwise spinning magneto, the drive for it had to be taken either from the crankshaft or from the rear cylinder's camshaft. Some magnetos have gears inside and should be driven from the crankshaft. This exact magneto must rotate with the same speed as the camshaft, so in the case of a crankshaft drive I had to make gears with different diameters, so I made 2 identical gears and took the drive from the rear cylinder's camshaft. Maybe the chain turned out to be pretty long, but it's not a big flaw. In the future I'll machine a bronze bushing and press it on the front cylinder's camshaft, which will expand the chain from the inside, thereby acting as a chain tensioner. So I marked it, machined 2 steel donuts, and made the chain teeth with the angle grinder. Then machine seats for the bushings, press the bushings into them, ground everything on the case that was on the way, and tack the bushing seats to the case. To choose the diameter of the studs for the followers, I scored some valves that were lying around and chose valves with 9mm stem out of a Gas 52 engine which lies on my second yard. For these valve stems, I machined follower bushings out of Dnepr valve guides, but a little later I made 3 of these bushings out of Gas 52 valve guides. For these bushings, I machined seats and pressed the bushings into them. The follower rollers were machined from the same long-suffering Dnepr camshaft and hardened in oil. Although I'm still not exactly sure what metal a Dnepr camshaft is made of, and if it's a malleable cast iron, then I'm just an idiot trying to harden cast iron. The follower roller pins I machined out of stainless steel. In Indians, pretty often you can see these pins made out of copper or bronze, so in my case, stainless steel will suit these rollers just fine. After that, this birdhouse lost a part of its roof, and having set the follower studs, I tack welded them in place. Then I made the follower frames from a piece of a leaf spring. A piece of a leaf spring because then I thought that the followers will work directly with the lifter, so the metal in them should be pretty hard. Drilling a leaf spring is a pleasure, but thanks to the drill press, which I still haven't maintained, I managed to succeed. Next, the L-shaped roller pin frames were made and were welded with stainless steel to the followers. Welded the follower frames to the seats with stainless and riveted the stainless roller pins. After all these procedures, I began attaching the magneto. For these purposes, I machined another shaft and 2 bushing seats. According to the classic scheme, from a couple of pieces of rusty junk, I made a metal ear on which the magneto will hang. According to the same classic scheme, a 22mm orifice was made. Drill a bunch of small holes, knock out the piece with a chisel, and file it to a round shape. Press the bushings into the seats and also press the gear onto the shaft. I'm too lazy to make a keyway, so I just welded the gear to the shaft. Then I fitted everything in place along with the seal and tack welded the seat to the magneto ear. Having received the desired piece of chain by harassing it, I began setting up the magneto ear and then welded it to the case cover. Machined 2 more bushing seats, pressed the bushings into them, and began designing a high-tech timing cover from the same scrap metal from which everything else in this burn house was made. Looks like I was wrong in the first video about I'm not gonna cast rubber roll pipes and make sheet metal, because the nearest place where I can buy metal is 50 kilometers away, which every time gives my laziness motivation not to go there and purchase some sheet metal, but to fool around with independent sheet metal production. In this case, these 3 pieces of scrap metal used to belong to a cage in which chicken lived. So now it's more logical to call this horrible work of art not a birdhouse, but a chicken coop. So having cut off everything unnecessary, I massaged it a little bit, made the chamfers, and welded these 3 pieces of high-tech scrap metal into a pile. And in no less high-tech way, straightened the plate which got tweaked after welding. Then I sawed off everything superfluous, added the missing, and got a workpiece for the future timing cover. In order to successfully tack all the seats to the cover, I made spacer bushings for the followers, again from Dnepr valve guides, as well as a spacer for the crankshaft gear. At the same time, I picked the key to the crankshaft gear, set the plate by eyeball, and welded all the seats to it. Being satisfied with the result, I ran to my pile of junk metal in order to continue rubbing it, and for the future timing case I found the rustiest piece of 2mm scrap metal. Cut off the right piece, cleaned it, and thanks to nanotechnology I made the bands of the desired shape. Around this time I felt like I have to get the bushing seats welded, and of course they got distorted. But fortunately I found the reamer of the required diameter instead of the universal one. After that, this case made of vibranium was successfully tacked, and then welded solid. Besides the air, the cover should be connected to the case with something else, so the work on manufacturing a threaded flange began in order to attach the cover. Everything here is the same way as usual: drilling, cutting threads, welding nuts for additional strength. Marked future places for the holes in the cover, drilled those holes and bolted the flange to it. After all that, I really wanted to cut off everything unnecessary from the cover, just because I love cutting off everything unnecessary. Pieces of previous scrap metal trimmings came to my hands, so I decided to make cover guides out of them by welding them in random order. After tacking the flange to the case, I took off the cover and welded the flange. I won't go into details about what happened next. In a few words, I'll say that after the flange, I began making the lifters, which supposedly should have been here. Also made them from gas 52 valves and valve guides, machined seats for these guides from a giant nail puller, and made a platform from scrap metal. I refused of them simply because the push rods didn't aim at the lifters. Therefore, this whole lifter assembly was removed and carefully put in a safe and dry place. After that, I welded the follower stud seats with just beefy tacks. Simply because by lowering and raising the follower assembly, we can adjust the valve overlap. The valve overlap, the moment when both valves are open, is necessary for better cylinder purging. Specifically here, I made the valve overlap approximately the same as the Dnepr overlap, but it can be changed at any time by lowering the follower assembly closer to the cam lobe, thereby increasing the valve overlap, because both followers will come closer to the wider part of the cam lobe. Or, in order to reduce the overlap moment, we can raise the follower assembly a little higher. Having dished the lifter assembly, I started making, so to speak, a more simplified system. Said motorcycle has its push rods point to followers without lifters, but there it's possible because the push rods point directly perpendicularly on the followers and don't exert any side loads to them. In my case, push rods point to the followers with a slight angle, so they do exert side loads, and to reduce these loads I added stop plates supported by bronze bushings that are welded to the sides of the followers. According to the theory that I created for myself, these stops should keep the followers from lateral travel, but we'll see about that in the future. Then I made these, as I call them, push rod rests. And after some tests, I welded them onto the rockers and made a new top cover out of old scrap metal. Them stop plates are made out of stainless and welded them to each follower. Then I welded, as I call them, stumps into which the stop plate studs are screwed in. The rear cylinder exhaust follower demanded more space, which was provided with the grinder without any problems. By the way, the weight difference between the followers turned out to be within 1 gram, which I was quite surprised about considering the method with which they were created. I made the bushings for the stop plates out of an old gramophone parts. And yes, at least by touch, the follower's play is completely gone, and the only movement the follower makes is radial. After that, I welded the top plate in place. Next is my favorite part, cutting off unnecessary and making flanges. I made the top flange in the same way as the bottom one and welded it in place. For this time, we only have to sew up the timing case on the backside, of course with scrap metal. Welded it and even ground it clean, which I usually don't have the patience for, or I'm just too lazy. As a result, this whole cover began looking quite acceptable as one complete piece. For the finish, the birdhouse itself lost another piece of its roof. People were also interested in what power the thing will make, what maximum RPM will be, but honestly, for me personally, it doesn't matter at all. What matters to me is that it starts, runs, and drives. I mean, the thing should move itself and move something that will move me. I'll tell you a little about the future lubrication system of this thing. On the cam cover, right at the tip of the camshaft, I'll make holes and put oil pumps from KMZ K750. The first oil pump will be practically stock, so it'll simply bolt on here and it'll be responsible for pumping oil into the engine. It'll feed oil to the crankshaft, to the rocker arms in the heads, and to the cam chest. On the second camshaft, we'll have the second oil pump, but it will be doubled, like paired, and it'll be responsible for pumping oil out of the engine and sending it back to the oil tank. So it's a scavenge pump. Also, one day I had an idea to make an oil pump that'll be responsible for all the work at the same time. It'll feed the engine and pump the oil out of the engine. Yep, sort of like a Harley pump, but mine will be a plunger with a lobe drive type of pump. Probably eventually I'll make it and won't torture poor K750 oil pumps. But for the first run, we can go without an oil system whatsoever. This is the advantage of a roller bearing crank over a plain bearing crank. Rollers don't need much lubrication. For example, a 2-stroke engine that has its crank bearings lubricated with meager particles of oil diluted in a gasoline. So I'll just put some oil into the timing case, lube the valve guides and rockers, pour some oil into the crankcase. The conrods will essentially be an oil bath, and they will also throw the oil up to the pistons, lubricate the cylinders and wrist pins. Also, in addition to a homemade oil pump, I have ideas about how to make a homemade carburetor and a complete homemade set of cylinders and cylinder heads. But again, all this probably will be only after the first start. Next, I have to attach the magneto. It'll hang right here at the back. Also, I have to make an intake manifold, make new valve recesses on the pistons, because, as I said in previous videos, pistons should be rotated 90 degrees, and to make a sump breather with a reed valve so the engine can breathe. Later, I'll have to spend some time for fine-tuning, because there are some parts that are made just hastily, and frankly, they need to be done properly. Also, I want to give the engine something like a cold run, break-in-ish type of thing. Basically, to disassemble it, clean it real good, put it back together, take out the plugs, throw it on the lathe, and just rotate it for a few hours. I'll catch you next time. Even if at first glance it seemed to you that everything is crooked here, I can assure you, my friend, that everything here is straight. I can assure you, my friend, that everything here is straight. I can see by eyeball from here that everything is crooked. Everything is straight, alright? Everything's straight, that's fine. But it will fire up, and it will work.